You're welcome once again to our maths and physics class. Today we are still continuing density, dimension of physical quantities, and we're starting with density. We will treat pressure alongside this. So, like I said, when you have physical quantities to dimension, what you do first is to write the formula. What is the formula for density? Density is equal to mass divided by volume. Mass divided by volume, and we can write that as mass is a fundamental quantity. We write that as m. What about volume? Volume is not a fundamental quantity. Mark you, volume is a derived quantity. Since a derived quantity, meaning it can be dimensioned or it needs to be dimensioned. What did we get last time? Last video, when we dimension volume, we had it that volume is the dimension is L raised to the power 3, L cube. That was the dimensioning of volume. So if mass is a fundamental quantity, we just transfer the first alphabet and we say we are representing it with capital letter M. Dimensioning of volume, because it's a derived quantity, it now becomes L raised to power 3. Okay, can we now write this as a straight line expression? Yes. In indices, law of indices, we said this can move up to multiply the numerator, and we have L. Instead of 3 as positive, it becomes minus 3. So it is no longer plus 3, it becomes minus 3 because it has moved to multiply the numerator. So in that case, we can now write it as M L raised to power minus 3. So how does this one relate to the SI unit of density? The SI unit of density now becomes, what is the SI unit of mass? The SI unit of mass is kilogram. Then what is the SI unit of length? The SI unit of length is meter minus 3. So that is why you have this as the SI unit of density. The SI unit of density is kilogram per meter cube, or kilogram meter raised to power minus 3. So if that one is understood, let us try to do that of pressure. Now, pressure, we are still going to start by writing the formula. What is the formula for pressure? The formula for pressure is equal to force all over area. Force all over area. Now, I want to ask, is force a fundamental quantity? No, it's a derived quantity, meaning you have to dimension it. Area, is it a fundamental quantity? No, it's a derived quantity, so you have to dimension it. But remember that we have already dimensioned force from our first video. We will not be dimensioning this under this video. We have dimensioned force from our first video before. Look at it. What is the formula for force? Force is mass times acceleration. What is the formula for area? Area, we considered rectangle that time. What was it? The dimension of area was L raised to power 2. The dimensioning of area was L raised to power 2. What about the dimensioning for force? Let us start by using the formula. We said the fundamental quantity of mass is what? M. We said the fundamental quantity here is mass, and we are representing it with M. What about acceleration? Acceleration, we said, is velocity divided by time. What was the dimensioning of acceleration when we discussed? Velocity all over time. And velocity, we have what? Distance meter, that is distance all over time, distance time raised to power 1 or minus 1. Then over what? Acceleration, the time. The other time was over time. And at the end of the day, we have t over 1. All of this divided by L raised to power 2. So let us deal with this. From that dimensioning of acceleration of force, we said it is what? M L T raised to the power minus 2. That is mass times distance times time raised to the power minus 2. So it becomes mass, that is kilogram, meter, second raised to the power minus 2. All these ones still divided by what? L raised to the power 2. So we are saying that pressure is equal to force over area. What did we discover, or what did we dimension that time from force? That is what we have here, mLT raised to the power minus 2. So if we have mLT raised to the power minus 2, we would have just taken this and bring it here to represent force. But we are doing this for your understanding, so that you get a better understanding of what we are doing. But if you are followed us on our videos or our classes so far, you will remember that we have mLT raised to the power minus 2 as what? The dimensioning of what? Force. Then we have area. Area is what? L raised to the power 2. So let us bring that one down to this place. mLT raised to the power minus 2 all over L raised to the power 2. Now let us apply the law of indices. The law of indices, what we have here? We have L and L. They are dividing each other. So we'll pick one. That is what the law of indices, that is the law of division says. We'll pick one. We have M. We'll bring it down. M. We'll pick one of this L. L. Remember, this is L raised to the power 1. So I can say 1. Because it is division law, is 1 minus 2. Then we have the T. T raised to the power minus 2. So what is L raised to the power 1 minus 2? 1 minus 2 is what? Minus 1. Then we have T raised to the power minus 2. So if I want to bring this as in bringing them down, bring the negative reciprocals as denominator, it becomes what? M all over L raised to the power 1, T raised to the power 2. So how does this one now relate to the SI unit of pressure? The SI unit of pressure now becomes, this is mass, kilogram, divided by or per, length, meter, seconds, square. So mass, the SI unit of mass, kilogram, the SI unit of length divided by this, divided by the SI unit of length is meter, and the SI unit of time, second. So you have this as what? The SI unit of pressure. So the SI unit of pressure, when you want to write that as in the component of it, is kilogram per meter per second square. So, but you find that in most cases where you are giving questions or when you are giving parameters in questions, you might not see that as the SI unit of pressure. But note that this is the component of the SI unit of pressure. Yes, so that is why you have that as the SI unit of pressure. But when we are giving questions or we are giving quantities to find, what do we have as the SI unit of pressure? If for instance you find pressure and it is 12, what do you have? You say Newton meter square per meter square. That is what we have when we treat pressure as SI unit. So the SI unit is Newton meter square. So where does that one come from? Look at the formula that we wrote from the first time. We said pressure is equal to what? Force times force divided by area. What is the SI unit for force? Newton. And that is the Newton you have there as Newton divided by, what is the SI unit for area? Meter square divided by meter square. So that is how it is gotten. And if you relate it to what we have there as the SI unit derived from the dimension, you see that mass is here, mass all over the distance. Then we have the time. So we have mass, distance, time. All combined will give us this Newton per meter square. So relate it to what we have here as Pressure is equal to force. Force is Newton. Newton divided by area, which is meter square. It is Newton per meter square. So all these ones, which we have gotten from the dimension, translates to Newton per meter square. So the SI unit of pressure becomes Newton per meter square, because the name of the man who still worked on force is still reflecting on that formula. So that's where we'll end. Please follow us, subscribe to our YouTube channel, share our videos, make comments and like. Thank you for watching.